Live from the North Carolina Museum of Natural Sciences in beautiful downtown Raleigh. It's the Science Cafe with your host, Chris Smith.
Hi, everybody. Good evening. Happy Thursday. Welcome to the North Carolina Museum of Natural Sciences for the Science Cafe. This is when you have the most fun you could possibly have at a science museum on a Thursday night with me. Maybe that was too many caveats, but welcome to the cafe. Thanks for coming out tonight to learn a little bit about what's going on right here in our community. I mean, every Thursday night for the Science Cafes, we try to find guest speakers to come onto the stage and share with us what's going on in the world of science, technology, engineering, mathematics. What's happening out there in the world? How does it apply to our daily lives? How does it impact us? Or maybe there's just something really fascinating that lots of people want to learn about. And we can bring those topics right here to you and in a cafe so you can grab a drink or have dinner right before we get started or during. So take advantage of those things too while you're here. But for tonight's topic especially, I think we've got something that is very local in that depending on where you live, maybe around the Triangle, you have ingested tonight's topic, right? Who had a glass of water today? Who had a glass of something made with water today? Or yesterday, or the day, right? It's you. If you had coffee and your water comes from Jordan Lake, then you probably want to know what's in your water. Or maybe if you just turned on the tap, you want to know what's in your water. And Jordan Lake and Falls Lake also in this region don't have the best reputations, I think. They're in the news too frequently for my own taste for where my water comes from. Now, I'm fortunate. Maybe my water does come from Jordan Lake. I should probably pay attention tonight. I might learn something. But so when I was a student studying environmental management at Duke, one of the classes that we all had to take, first semester students, was GIS, Geospatial Information Systems, how to make maps for scientists. And one of the things that we learned how to do was make a watershed map. And I remember pulling data for a part of North Carolina and then running really simple analysis just to see how big the watershed was, where you could expect to see water accumulating, and then all of a sudden I punch in the numbers and on the computer screen shows this map, and there's this intricate spider network of blue veins coming across the map moving in front of me. And I realized that even where I was sitting in a classroom, that I really wasn't too far from a source of water. That, just right outside the school building, I could probably find a place where water would collect and then flow into a bigger body of water, and then a big one, and a big one. And then these things end up in lakes, rivers, streams all around us. And then that's how we survive. That our water goes through this incredible process of moving around us. And then that's where we get our drinking water. That's the water that we bathe in. And that's the water where we brew our coffee. And that's the water where we brew our beer. Our beer, people. So tonight we brought in an expert who knows a lot about what's going on at Jordan Lake, someone who's working on the issues surrounding that lake, to give us a little bit of insight into these issues and maybe even a little bit of what we can do about it and how we can impact the community around us to improve things like water quality. He's Joseph D'Alessandro from UNC Chapel Hill, a PhD candidate in environment and ecology. Put your hands together and welcome Joseph to the stage.
Well, thank you for that introduction, and thank all of you for being here. That was a great introduction, and I'm just going to jump right in here. So this map, I'm going to be using the screens a lot. Sorry about that, but I like my visual aids. So this map here is a map of all of the impaired waters in the continental United States. So these are lakes, rivers, streams, wetlands that all have some sort of water quality problem. So water quality in the US and globally is a large and growing concern. And the Research Triangle region is really no exception. So you'll see 2 lakes on this map here, and one of these right there is Falls Lake. So if you live in Raleigh, this is where your water comes from. And this one down here is Jordan Lake. I'm going to talk mostly about Jordan Lake today. And if you live in Cary, that's where your water comes from, a few other places. But these water bodies are critically impaired at times, and mostly for algal blooms. And so, what are algal blooms, right? So algal blooms are fed by excess nutrients coming off of the landscape or being cycled in the lake. So these nutrients are nitrogen and phosphorus mainly. I'm going to be talking mostly about nitrogen today because it's easy to measure, but also because some new research indicates that it's the more important of the 2 nutrients for Jordan Lake. And these excess nutrients, they come off of the landscape from many different sources. They cycle within the lake, and they feed this growth of algae. And this algae is really just that green mess that you might have seen out in these lakes or maybe at other small water bodies. And the algae creates really toxic environments in these lakes where it's really difficult for ecosystems to survive, fish die, and this really threatens the quality of our drinking water and also the potential for these lakes to be clean, safe recreational spaces. So the Jordan Lake Nutrient Management Study is a pretty large project consisting of many different researchers, and some of the researchers are studying this cycling of nutrients and water within the lake. Some of them are studying the transport of pollution and nutrients with sediment. Others are studying the exact factors that actually control the growth of algae within the lake. And then we have people working on public outreach, working with stakeholders, and looking at ways to finance solutions. Today, I'm going to spend most of my time talking about my part of the research, which is figuring out what are the important nutrient sources for nutrients coming off of the watershed, coming off of the landscape, and feeding this pollution. All right, so this is a land use map. And you'll see that there are, well, so right here in the bottom right-hand corner is Raleigh, and then this big red blob over on the left, that's Greensboro. And the black outlines here are the watershed boundaries. So all of the water in those boundaries will eventually flow to these 2 lakes on the left. This is the Jordan Lake watershed, and on the right, this is the Falls Lake watershed. So you'll see that there are lots of different land uses within these watersheds. The reds and pinks, those are the urban areas. The yellow and brown, that's different type of agriculture. And the greens are forested areas. Now, both of these reservoirs were created or at least expanded in order to provide clean drinking water for growth in the region. But you'll also notice that there are a lot of these big red urban areas that are within these watersheds. So the very growth that they feed happens within these watersheds. And this development can be really important sources of pollution. And the pollution will wash off of these landscapes, or it might be discharged by industry or from wastewater treatment plants, and that makes its way back down to the lake. So we need clean drinking water to support growth, but that very growth is actually hurting our chances for having future clean drinking water. All right, so there are solutions to nutrient management and water quality issues, and that's the whole point of the Jordan Lake Nutrient Management Study and the plans that it will inform. But in order for those plans to be effective and efficient, there are a few things that we need to know. So first, what are the major sources of nutrients within these watersheds so that we can try to limit those sources. Where are they coming from on the landscape so that we can try to intercept that nutrient pollution? And then how are they moving from the landscape into these water bodies? So Chris was talking about those complicated flow paths. We'll talk more about that later. But if we know how they're moving from the landscape, we can try to prevent that transport. And then when are they moving into water bodies? So when I say when, I'm talking about during what seasons, under what flow conditions, during storms, or during the drier periods between storms. Okay. So urban sources, urban areas have many different nutrient sources, lawn fertilizers, yard waste, pet waste. How many pet owners are in this room? All right, pick up after your pooch. Atmospheric deposition. So this is just dust and compounds that literally fall out of the sky. Some of this is from air pollution, but the atmosphere is 78% nitrogen, so some of that is just natural. The soil is, of course, full of nutrients, or nothing could grow. But so some of that is natural from plants and microbes, but also the soil can hold on to past pollution as well. And there are two other really important nutrient sources below our feet, right? So how do we deal with our wastewater? So some areas are, first I should say wastewater is very nutrient rich. When we flush the toilet or wash food scraps down the sink, we are putting nutrient rich material into these systems potentially. And some areas are on septic systems, right? And so these are systems that sit underground, especially rural areas. These are systems that sit underground that collect this waste. They provide some amount of treatment, and then they release this nutrient-rich water slowly into the ground. And then more rural areas are generally on sanitary sewer systems. So these are big pipes that collect wastewater and transport it to a wastewater treatment facility where it can be treated. But unfortunately, a lot of these sanitary sewer lines leak and can become pretty large potential sources of nutrients. All right, so if these nutrients are just sitting on the landscape, then they're not an issue for the water quality of streams, rivers, and Jordan Lake. But when these nutrients come into contact with moving water, they can dissolve into that water and be transported off of the landscape into streams and eventually rivers and make their way down to Jordan Lake. So water can move across the urban landscape or any landscape in that matter in many different ways. So it can take these surface pathways where it flows very quickly over the surface of watersheds. It can infiltrate into the soil and take these slower subsurface flow paths, or it can infiltrate deep into the ground. Infiltrate is just a fancy way of saying soak. So it can soak deep into the ground and make its way to become groundwater and very slowly feed out into these streams and rivers. And these flow paths are really important because one, they're controlling that how that we talked about, how these nutrients are moving into the water bodies, but also to some extent which nutrients are being intersected in these different flow paths. Now, urban areas can also, I keep saying urban areas, but let me clarify. I'm talking about any sort of developed area. So even if you live outside of town in a place that we would generally call rural, scientists kind of lump that all up as to urban development often. But so let me say, so these developed spaces can also change the hydrology of the area, change the way that the water moves across the landscape. And they do that primarily with impervious surfaces, right? So roads, parking lots, this nice deck here are the roofs of our houses. These are impervious surfaces that water can run off of quite quickly. Did anybody go outside during that big storm on was that Sunday? No? Okay. I'm a hydrologist, so every time it rains like that, I got to get my stuff on and go out and take a look. But the roads were gushing, right? They were rivers with all of the water that collects along the curb and flows off of the system. And eventually that water goes into stormwater pipes if you live in a city, and that will basically shunt that water directly into streams where it will make its way down to Jordan Lake. So urban areas can have quite a large effect on these flow paths in urban areas, or of the flow paths in the landscape, in addition to what these different nutrient sources are. All right, can kind of see this, maybe sort of. All right, so this is actually exactly what Chris was talking about before, that web, that network of flow lines. So this is a model for a flow model for an urban area. So all I've done is I fed it in a elevation map, like a topographic map, right? And I give it one rule, which is that water flows downhill. Pretty simple. And it creates this map of all the different flow lines that water will take. And if you're sitting close enough to a stream, you might to a screen here, you might be able to see that in this map, these flow lines follow a lot of gridded patterns, and those gridded patterns are, of course, the roads. So these roads are creating a highly connected network that can move water very quickly off of the landscape. All right, let's compare that to a forested area here. And so if you can see this, these flow paths are much more windy, and they're much longer than the ones from the urban model. And this means that the water is taking these longer paths. It has more of an opportunity to infiltrate into the ground. And once it does so, there's the chance that organisms or plants might pull the nutrients out of that water. All right, and finally here we're looking at a map for a rural area. And so it's somewhere in between. We see some of these flow paths following roads and some others that are quite long and windy. Excuse me. But this neighborhood actually happens to be on septic systems. So even though a lot of that water has the potential, at least, to infiltrate, as it infiltrates and flows through the soil, it has the possibility of intersecting those subsurface sources, in this case, the septic systems, and transporting those nutrients. All right, so this is the way that a hydrologist kind of looks at this problem. So on my horizontal axis here is time, and on the vertical axis is flow. And that red line is basically so flow is just the amount of water heading downstream if you're measuring at the bottom of some watershed. And this red line here is for a highly urban area. And you'll notice that it has this high peak, very short intensity, or very short period of time in which all of this water is coming through the system. And in a rural area, that is a much lower peak, and it's spread out over a longer period of time. And so this concept is really important because generally, we find it easier to treat slower moving water, slower moving nutrients and pollutants, than these really fast moving pollutants coming in these huge pulses of water. So if there were a bunch of nutrients in that water rushing along my curb on Sunday night, there's really not much we can do about that. It's just moving so fast in such a large pulse. So this timing and magnitude are really important factors. And here's some real data. That was just a cartoon, but here's some real data where we can look at that for a period in April, about now, from a few years ago. And the red line is a high-intensity urban area. This is near downtown Durham. The orange line is a medium-intensity developed urban area. This is probably the sort of neighborhood where most of you live. And then the last one is kind of the lower intensity urban area on the outskirts of town. And you can see they have very different patterns in how the flow comes off of these landscapes, how the flow behaves in the streams and these watersheds. So in the urban area, you have these large, quick pulses, and in the low intensity areas, we see more, much more gradual changes. And so even within developed urban areas, we see that there are fairly large differences in the way that the hydrology behaves. And that's really important because not all urban areas are the same. There's a lot of variation in urban areas. So this is, I think we're on this map somewhere in here, yeah. So this is the land use map for the area from Raleigh up through Umstead here. And you can see that there's a lot of different variation in these land uses. I mean, just think about where you live, where you work, where you shop, where you listen to talks about water quality. These are all very different landscapes. They have different nutrient sources, and they move water and transport nutrients differently. All right, so let me sum up my little introduction here. Development has many different nutrient sources. It changes how water transports these nutrients, and it can be very different from one neighborhood to the next. All right, so how do we study these highly variable landscapes so that we can determine what the major sources of nutrients are, where they're coming from on the landscape, how they're being transported off the landscape into our water bodies, and when, under what flow conditions that's happening. So this here is another land use map. I hope you guys are getting familiar with these. This one is for the Chapel Hill and Carborough area. So Chapel Hill is over here, this red stripe, that's Franklin Street. And this black line is the watershed that encompasses this area. This little green dot right down here, this is a sampling point. This is an old sampling point that has been sampled for quite a long time. And pretty much all of the water in that watershed flows to that point. And that's interesting because it allows us to go out and sample that one point and learn something about the water quality of that really large area with just one sample. But you'll also notice that there's a lot of variation within that watershed. Not just variation in the intensity of urban development and the amount of forested space, but there's also variation in the type of urban infrastructure that exists. So places that are on sanitary sewers versus areas that are on septic systems. What's the abundance of stormwater pipes? Do the roads have curbs or not, right? The curbs kind of make rivers out of some of these roads collecting water. So these changes in infrastructure and changes in land use aren't really captured, their effects aren't really captured by just sampling at one point like this. So for the Jordan Lake nutrient management study, we're doing things a little differently. We're studying smaller watersheds. So we call these single land use watersheds. These are small single land use watersheds. And by doing this, we can kind of isolate some of these variables. So for each of these watersheds, we calculate all sorts of fun statistics in this GIS that Chris was talking about, Geographic Information Systems. We can calculate statistics on the percent impervious surface cover, the density of roads, the prevalence of septic systems or sanitary sewers, and by selecting our sites to span ranges in different potential nutrient sources and different hydrologic conditions, we can isolate some of these variables, right? We're just controlling for variables so we can study these factors independently. And by studying enough of these sites and comparing the water quality coming from these watersheds, we can really get at those first two factors of the what are the important nutrient sources and the where on the landscape they are coming from. All right. And so that still leaves us, of course, with the how and the when. So this here is a hydrograph is what we call them. And on the top here is the precipitation record for a period from last September to this February. And these little green dots are nitrate nitrogen concentration from grab sampling. And this is the typical way that we would study the water quality of some stream. We'd go out whenever somebody was available and collect some water. We'd take it back to the lab. We'd process that sample. We'd run it through an analytical instrument. I'm putting some of you guys to sleep just by explaining this process. But that's how we traditionally would measure water quality. And this process misses a lot of variation. You have to interpolate between these points, basically make guesses as to what the water quality was between your sampling days. And so here I've added the flow during this same period. And so you can see that there's a ton of variation in flow, mainly resulting from storm events during this period. And this grab sampling traditional collection of water quality data isn't really capturing a lot of that variation in flow. All right, so what are we doing that's different on the Jordan Lake Nutrient Management Study? We're using these cool gizmos. So these are in situ spectrometers. And spectrometers are basically the tools that we use to analyze water quality in a laboratory environment. And now we have packaged them up into these cool tubes so that we can actually drop them right into streams to continuously measure the water quality. No need for us to run out and collect the sample and bring it back to the lab. That's being constantly measured in the streams. And we can do this in some really small streams. So this is just a little, this is a watershed, the stream that's draining a watershed in North Chapel Hill. It's like 2 neighborhoods in this watershed, pretty small stream, and we can fit one of these sensors in there. Here are a couple of our research assistants. They're out there cleaning the sensor, downloading the data. Got to do that every couple of weeks. But so we can continuously measure water quality in large rivers and lakes, even in these small streams that give us a lot of resolution in how land use affects water quality. All right, so what does this data actually look like? So at first, this might look like a bit of a mess. So these green, so I've put the grab sample data now in dark green, and the light green is that nitrogen concentration. And you see that we have all of these huge peaks in concentration of nutrients that are coming out with these storm events that are not captured at all by our grab sampling regime. And so this is really important because this is helping us to get at that question of when. We can now differentiate which of these nutrients and at what concentrations they're coming out during storms versus during dry periods. And we can go a step further, and we can actually look at the patterns in nutrient concentrations during storms. And, oops, there we go. And you might notice here during this storm from a couple months ago, from January, there's actually 2 peaks in nutrient concentrations with this storm. And so this allows us to kind of think about that question of how these nutrients are moving off of the system. So we get this first peak here on the rising limb of the storm, or the rising limb of the response to the storm. And so this is that really fast moving water, right? It starts raining, the water runs over the surface. That's the first water into the stream. And so that's what we're measuring here in this first pulse of nutrients. And then we have the second pulse here. This is water that's taking a longer time to get to the stream. So it's most likely infiltrating into the ground, traveling through the soil to get to the stream. And so by looking at the timing of these nutrient pulses within storm events, we're able to determine which flow paths those nutrients took to get to the streams and rivers. All right, and then this is, I think, actually really neat. This is us measuring the change in nutrient concentration just over a few dry days here. And so what we're actually able to measure is the uptake of nutrients from plants and microbes and algae in the stream throughout the day. And this is really interesting because it gives us the potential to look at how natural processes and restoration can potentially be used to reduce nutrient loading. All right, so once again, this is just a small part of the nutrient management study. And there are a lot of other great research teams looking at the processes actually going on within the lake and how we can integrate with our communities to make these things, to make solutions to these problems actually happen. But we hope that this information on the external nutrient sources, on these watershed-derived nutrient sources, will really help to inform the different solutions to this problem. So one way that we could do that is by public outreach and policy and rulemaking that limits the nutrient sources that are most important. We can use this information to inform what and where best management practices or stormwater control measures should be installed. And these are just methods that we can use to intercept and treat nutrients through mechanical and natural processes. And then I think most importantly, this information will be vital for informing low-intensity development. So the next generation of communities in this very rapidly growing area that will pollute less and enjoy cleaner water. All right. So with that, I'd like to thank you all for listening to my spiel. I look forward to your questions. But I'd also like to go ahead and mention a lot of the professors that work on this. So Diego Rivera-Sarregue at UNC, Larry Band at UVA, John Duncan at PSU, and then Aaliyah Walsh, who's sitting here looking really bored, but she's a very passionate environmental scientist, is the research associate on this project, and along with a small army of enthusiastic undergrads, they've been able to collect a lot of the data that's made this work possible. So with that, I look forward to your questions. Oh, let me also just throw up a few links here. You can shoot me an email here, or this link here, the first link there will take you to the Nutrient Study Symposium webpage, where there are a bunch of presentations from the other researchers on the project if you want more details. And then there's the Jordan Lake Observatory website as well there. Dr. Rick Ludick has some really cool sensors actually out on Jordan Lake that are continuously taking measurements of water quality, and you can log onto that website and actually see the footage from a webcam on them, but then also see the data coming off the sensors live. It's pretty cool. All right.
Let's give him a round of applause.
Thank you.
Thank you very much. All right, so the way Q&A works is you raise your hands and ask him questions, and I'll bring a microphone to you so that everybody in the room, I can make sure everyone can hear. So flag me down if you've got a question you want to ask. I see one over there. I actually want to ask the first one, though. When you're going out in the rain, as a hydrologist, what are you looking for? What makes that so exciting?
I'm looking for where the water's coming from and where it's going, basically. So there's this process of runoff generation that I think is really interesting. So there are places in the landscape where the water will infiltrate into the soil, and there are places in the landscape where that water is going to pool and run off and create like temporary ephemeral channels is what we would call them. And that's actually like a really intricate and interesting process. We build these models that I showed you, the squiggly blue and yellow lines, but you never know if they're right until you actually go out during a storm and say, oh, yes, there is water there. So I think that's the main thing that I'm looking for when I go out in the storm. It's also a great reminder of just how powerful nature is. So especially in these urban areas, I'm sure if you live in Raleigh, you're probably aware that I think that's over by the Crabtree Mall, where the Crabtree Creek comes underneath the road, and occasionally that floods. I was actually nearby one year when a big storm came, and just watching all of that water gush down this small urban stream was just incredible. And these are really incredible processes.
Like your investigations, I guess you generate policy recommendations to government bodies, local, state, I don't know where.
Sure. So,
And are we, in these watersheds that you investigated, are we close to the state of the art in how to manage them, or we have some big gaps? And if so, what are they?
so that's a great question. So the goal of this research is to inform that sort of management. So what I can say for certain is that in terms of the research and the science that we're doing to inform these plans, it is certainly the state of the art. In terms of the actual policy and rules that we have in place, I think we've got a long way to go to get to a point where we can feel good about the sustainability of the falls and the Jordan Lake water bodies to provide good recreational areas and clean drinking water sources through the future. I'll say that we are funded to continue to work on this project, or we've been mandated to continue to work on this project for about another year and a half on the Jordan Lake watershed. And at that point, we'll take all of this science from all of the different researchers, and we'll integrate that to create policy recommendations for the General Assembly. And then this study will move on to start looking at Falls Lake in, I believe that will be 2019 to 2021. And it will once again make policy recommendations for the Falls Lake and the Falls Lake watershed. Did I answer your question?
I saw a preliminary report or an interim report or something like that from the group, which unfortunately had no data with it. But amongst the conclusions stated was that septic tanks, septic systems were contributing to the nutrient load. You didn't mention any data tonight particularly relevant to that, and I wonder if you could say something about how it is that that's been determined.
Sure. I hit all of my data, but I've got it in the back of this slide deck here. Okay, so that's a great question, how that's been determined. And so actually let me start with a watershed that's on a sanitary sewer system. So that's what I'm showing on this graph here. And you can see that we have this storm event starting right in here. This is where the precipitation is going up. We see this increase in water level with the storm event, and very quickly we see this large peak in nutrient concentrations, followed by a rapid dilution as all of that that rainwater dilutes those nutrients. And so what we infer from this is that we're getting these nutrients that are being coming off of the surface in that fast-moving flow and basically flushing the surface of nutrients. And that has a large contrast to what we see in a watershed on septic. So now this is a hydrograph for, I believe, the same storm for a watershed on septic as opposed to sanitary sewer lines. And we see to some degree the same pattern in this tiny little pulse of nutrients at the beginning of the storm, but then we get this secondary pulse, a much larger and longer pulse of nutrients coming out on the receding end of the storm. And we know that these, because of the timing of that flow and of those nutrients, we know that these are coming through in these subsurface flow paths that are intersecting those septic sources of nutrients. So that's how we've come to that preliminary conclusion. Now, there are ways that we are going to check that using isotopes. So the isotopic signature of nitrate for water that comes from the atmosphere, from surface sources, from the soil, can be very different from the isotopic signature of nitrate that comes from wastewater. And so we're collecting sampling right now to just double check that conclusion to make sure that that really is wastewater that we're measuring.
Hi, I'm going to ask just for an opinion, so no
Sure.
right or wrong answer, but you're certainly an expert more than I am. Some years ago, I was on a little town board thing where we looked at, among other things, the uses of wetlands. And of course, the Army Corps of Engineers and others sort of tell you what you've got to do, but there was a lot of flexibility in what we decided. The bottom line was that we tended to want to protect even tiny little bits of wetland. This, to put it mildly, enraged the developers and the landowners who were hoping to make what they considered better use of those wetlands, especially if they in fact owned the wetland and were being told that they had to leave it alone. In your opinion, were we being a little too protective? Would a tiny little bit of wetland, and I'm talking like maybe a tenth of an acre or a quarter of an acre, is that significant in terms of trying to protect ultimately the drinking water?
So it's funny that you asked that question, and I can give you I don't have to give you an opinion. I can give you some facts on that one. So this is actually the first thing that I studied coming out of undergrad. I worked as a research assistant for a professor, Daniel McLaughlin, studying the importance of the small wetlands in the landscape. Right, and so the first thing I think to know about wetlands is that we often refer to them as like the kidneys of our water system. So these are low areas where water can collect. Thank you. These are low areas where water can collect, and there's a lot of biological life that's happening in there. And so it provides a place where water can infiltrate, but also there are all sorts of organisms that are able to uptake those nutrients and store them for a long period of time. Sometimes they can store them in the soils, or sometimes they actually store them in their biomass. Now, in terms of the importance of small wetlands, I think one of the key findings from some of that research that I was a part of as a research assistant was that really the most impactful wetlands are sometimes these small wetlands that we find in urban areas, right? So if you go out into a nice pristine area and there's some big wetland, well, it's a beautiful place, it's great habitat, but the water out there is already pretty clean, right? But these small wetlands where we find them in developed spaces, they have a really huge impact on being able to treat that dirty stormwater or that dirty runoff. One of the big solutions that people look towards for treating nutrient pollution, stormwater control measures is the broad category, but one of those types of stormwater control measures is basically artificial wetlands. Little ponds that we create with lots of reeds and whatnot, where water will drain into and can be partially treated by those plants. And sometimes these are very small. I mean, there's one in Carborough that's not even as big as this stage right here, but certainly they think it's quite important.
I have a small question. and also a suggestion. See, I am the manufacturer of nitrogen through septic tank and through my lawn.
Mm.
When I go and buy a bag of fertilizer from Home Depot and Lowe's, some of it runs away and some of it grows as a grass, right? But that grass, if I'm a manufacturer, if a policy could be there that manufacturers are responsible for some of my action. If I grow grass and I want to enjoy a lawn, green lawn, then I need to get back that grass I grew it back to my lawn through compost or through different means, so that there is some responsibility. And I heard you talk about outreach and education.
Mm-hmm.
This is the concept of manufacturer pay for the portion of the pollution. Like in Germany, when you build a car you have to take back the car as a scrap. So they reduce the unwanted material. That's my comment.
So are you referring to yourself as a manufacturer or the actual factory as a manufacturer?
I am a part of a manufacturer as well. So if there is a policy that I need to take back some grass through the, in other words, ration the fertilizer I can use in my lawn.
Yeah.
And that could be in a way of getting back compost grass, that eventually come back.
Yeah. And so there are, actually Durham has a yard waste outreach program that I think could be really important. And their goal is basically just to inform people about the fact that their grass clippings are full of nitrogen. They're full of these nutrients, to try to keep them on the landscape, inform people about how to fertilize your lawns. So check the forecast before you put any fertilizer down. If it's going to rain tomorrow or the next day or even the day after that, then just wait. Because if you put those fertilizers down and then it rains, they're just all going to wash right off, and it's not doing your lawn or Jordan Lake any good.
I know that some of the fixes for these problems involve restrictions on where development can take place and things like that, which are always really difficult and controversial to pull off. But are we close to having new engineering and tech fixes that could be implemented? I don't even know what I'm imagining, but I don't know, changes to toilets or new ways of capturing and hanging onto dog waste, or different kinds of curb and gutter that restrict the flow of water so from being as fast as it is when it's most damaging. Things that cities and that municipalities could do and could actually implement without having to get big voting blocks of people on board to try to minimize their impact on the watershed.
So that's a great question, and you hit the nail on the head there with these big voting blocks, because yes, there are things that cities could do, but they're expensive. So in order for them to pay for them, you're paying for it through your taxes, and so that requires a big voting block sometimes. So that is one of the main influences, though, of this project, is without this information, we would basically have to employ these methods willy-nilly throughout the landscape, cross our fingers and hope that they work. But with this information, we can be very targeted about where we employ these engineered technological tactics to reroute water or clean drinking water. And by being very targeted in that, we're saving money. So that's really the efficiency. So whatever plan ends up being informed, it really needs to be efficient as well as be effective, or else it's going to be really hard to sell to the taxpayers and ultimately to the General Assembly as well.
May I add one unrelated question?
Sure.
So since they're about to make a decision about the 540 connector that runs across the southern end of Wake County, I believe, and I think it's sort of a foregone conclusion that that will happen. And as I understand it, that runs through what's called the Swift Creek watershed, which I've heard described as the next likely water resource for Wake County after Falls and Jordan Lake. And I assume that having that great big highway running through there would have an impact on our ability to keep that water pristine. Do you have any comment about the wisdom of that decision?
That's funny that you say that. You guys are hitting on a lot of my past experiences. My capstone project for engineering was designing a bridge so that it would reduce the nutrient runoff coming off of it to sensitive lakes. Roads are always sources of nutrients and all sorts of other pollutants. And so there's these, I talked about that atmospheric deposition, so these nutrients that fall out of the sky. When they fall in a nice grassy area, it's not really a problem, right? They'll make their way into the soil, the grass will uptake them. When they fall onto a road, then there's no mechanism for them to be removed, and the next time it rains, they'll just rush right off into the nearest water body. And so that's the mechanism by which roads and bridges can be important sources of nutrients to nearby water bodies. So to put it very simply, yes, it potentially would be a water quality issue. There are lots of different ways that the Department of Transportation tries to balance those sorts of issues. So I'm not sure to what extent they're trying to employ those tactics.
Great talk, thank you.
Thank you.
Is fertilizer the biggest source of nitrogen, nitrate pollution, or is there something that tops it?
I think wastewater is the
Wastewater.
largest source of nutrient pollution, at least within urban areas like the Falls and Jordan Lake watersheds. So this could be coming from our septic systems. We know that to some extent it's coming from our septic systems. I think a large amount of it is probably coming from leaky sanitary sewer lines, and then we treat as much of it as we can, of course, but some of it is discharged raw on rare occasions, and then the treatment efficiency it's phenomenally high, but the amount of nutrients we're putting into the system is just so high, such that there's still a notable amount coming out of those systems, our wastewater treatment plants.
And one other thing, you talk about pollutions coming from the sky. Is that, what is the source of that?
So, right. So first there are all these combustion byproducts, and these are the ways that air pollution can influence this. So these are nitrogen compounds that are the product of combustion that can come out when it rains or settle out over time. We also just have ammonia can volatilize from fertilizers or from agricultural operations into the atmosphere and then come out. There are processes by which lightning will basically turn nitrogen gas in the atmosphere into nutrient potential sources of nitrogen.
I didn't know that. That's wild. Okay, next question.
One of the questions that I keep coming back to are riparian buffers and forested headwaters. Are you measuring that and how that impacts runoff?
Yeah, so we have forested watersheds, right? So anytime you do a study, you need to have some sort of a control. So we have a couple of watersheds that are just forested watersheds. We're just measuring what the patterns coming off of those are. Generally speaking, those are really this forested headwaters concept is a great idea. I mean, that's the way to keep this water clean, but that means we can't develop any of that land. So of course, you see we run into a big problem there really quickly. There are a lot of constraints on the development around Falls Lake, and I believe around Jordan Lake as well, to try and keep a certain amount of that area forested. But even small urban areas can have a pretty large nutrient pollution footprint. Now, riparian buffers, that's a really good point, because that comes back to a lot of the decisions that we make in terms of infrastructure. So first, I'm going to step way back and tell you a little bit about why I find urban areas to be such an interesting place to study these sorts of problems. Everything we do in an urban area, in a developed area, is the result of a decision, a design, development, engineering decision. And so that means that we can change our thought process in making each of those decisions and potentially have a large control over the outcome of how that system behaves, in this case regarding nutrient pollution. Now, we know that riparian buffers can remove a lot of nutrients from the water. So riparian buffers, for people that don't know, are forested areas along streams and rivers. And so when the water is making its way into those streams and rivers, they provide a buffer that can basically filter out that water before it hits those streams and is then transported down to Jordan or Falls Lake. Now, in urban areas, we have lots of roads and stormwater pipes. And so even where we create these riparian buffers, we often short circuit them by having drains that run directly off of roads into our streams, or by running that water into a pipe that goes directly into the stream. So these riparian buffers can have a large effect, but when we short circuit those buffers with pipes and roads, we can't really expect them to be that effective. Now, I should mention that the decision-making process there is a fairly good one. They're trying to prevent flooding. And so I think we need to prioritize or at least put more attention on these water quality issues when we are making these sorts of decisions, to see if we can achieve a better balance between flood protection and downstream water quality.
I had two questions. One of them was, I've lived a couple of places where during the summertime they had a manganese problem in the water. I don't know that it was a hazard, but it changed the color and smell, and everybody got all bent out of shape. I was wondering if you know what that's all about. But the second one is places like the city of Raleigh waste treatment plant, the end product is sludge, which always bothered me a little bit because it's something bacteria won't eat. Some of it's solids, which you know, like dirt, which no big deal, but I had a feeling that maybe there's heavy metals in there because bacteria don't really eat them, and they're heavy, and they end up probably in the bottom of whatever's going on. But city of Raleigh, the sludge injection fields are right beside the Neuse River, which struck me as kind of a curious location, but I wonder if you knew anything about that, and whether the heavy metals are a component of the sludge.
That's all right, so I'll start with the manganese. And I really don't know anything about what causes that. I think there's I think there's probably some mining operations that might cause that, or maybe some sort of a biogeochemical process. But I've definitely seen the videos of these like reddish brown lakes and rivers that are caused by it. Very, very eerie. All right, so the sludge. You know, I really wish I knew more about what was in that sludge. I'm sure somebody tests it. I'm sure that information is out there. I've been a little myopic on that topic. It's full of nutrients, so I can tell you that much. But I never thought about it that way. That is quite scary. Here you have this sludge that's full of nutrients. You'd think things would love to eat it, but they don't. So that's a pretty bad sign.
City of Raleigh Fields, there's several of them, say off a mile Plantation Road, and some of them about 40 feet from the river, and I mean it's sort of a steep downhill grade to the river.
Yeah.
So they obviously try to put them into a crop, mainly corn and sunflowers, but you know I'm sure there's bound to be some runoff, even if it's subterranean flow.
Yeah. So one of the things that we might be able to do with some of our mapping and modeling that we used for these projects is to identify areas on the landscape where we could put these this sludge, this nutrient-rich sludge, and it would have the lowest possible potential of making its way to the rivers and to the lakes.
Let's give him one more round of applause.
Thank you all.
Thank you for coming out,
Of course.
joining us in a discussion about our water. Well, I hope all of you learned something cool tonight. Take back, remember, putting fertilizer on your lawn. Take care of that stuff. Thanks, everybody, for coming out to the Science Cafe. Hope you enjoyed this Thursday night. Don't forget, we'll be back here next week, so I hope we'll see you again soon. Good night, everybody.